Okay, class, in this lesson, you will learn to find the points of concurrency or points of intersection for the medians of a triangle and their characteristics. Okay, so let's go ahead and get started. Okay, so what exactly is a median? Okay, a median of a triangle is a segment that has endpoints at a vertex. Okay, so let's say right here, vertex D. So the median has an endpoint at this vertex, and it extends out to the opposite side of the vertex. And what's unique about where it lands is that it is at the midpoint of side AC. Okay, so what this does is it cuts side AC exactly in half, and as a result, segment AB is exactly the same as segment BC, and that's represented by the hash mark on each side. Okay, so that is the median of a triangle. So obviously this is extending from one vertex to the opposite side, and so in any given triangle you could potentially have up to 3 medians. If we were to extend a median from vertex A to the opposite side, that would be a second one, and then a one from vertex C to the opposite side, that would be a third. Okay, so what we have stated here is that segment BD, which is this segment right here in green, is the median that bisects side AC. Okay, so it cuts AC exactly in half. All right, so let's take a look at the following theorem. This theorem states that the medians of a triangle, okay, so I mentioned that you can have up to 3 medians in a triangle, and each of these 3 medians, okay, intersect or are concurrent right here at point G. That is exactly 2/3 the distance from each vertex to the midpoint of the opposite side. So what this means is segment AG, for example, the length of AG is exactly 2/3 the length of the median AD. Okay, same. Likewise, segment CG is exactly 2/3 the length of the median CF, and then segment BG is exactly 2/3 the length of the median BE. Okay, and this concurrency here, or this intersection, is called the centroid. So here, what I've written down here is exactly what I said. Segment AG is exactly 2/3 of median AD, and then the same for BG and CG as well. Okay, they are 2/3 of those medians, BE and CF. Okay, so let's go ahead and try this next example. Okay, so our goal here is to find the length of a median, and in this case we want to find the length of median JN. Okay, we want to know what this length is, given the fact that JQ is 18. Okay, now before we even solve this, we want to make sure that this theorem applies, and what I mean by that is we want to make sure that these are all medians, and we know that because it extends from a vertex to the opposite side and it cuts it exactly in half. See these 3 hash marks? This implies that LN and NK are exactly the same length of segment. Okay, and same with KP, it bisects LJ exactly in half, and then LM bisects JK exactly in half. Okay, so we don't want to make any assumptions. So whenever you solve problems like this, you want to check to make sure that it is clearly marked that each of these sides are bisected. Okay, so now that we know that this is bisected, we can go ahead and use the theorem that we just learned, and we should be able to first start with the relationship of the segments. So what I mean by that is we should write JQ is equal to 2/3 JN. Okay, which is exactly what the theorem says. JQ, this segment, is equal to 2/3 of JN, okay? 2/3 of that length. Once you establish that relationship, then you can throw in the numbers, okay? Now we know that JQ is 18, so we can go ahead and substitute that in, and 18 is equal to 2/3 JN, and now we can solve for JN. Okay, so we multiply both sides by the reciprocal, and when we do, these cancel each other out. The 2's it cancels out, the 3's cancel out, and now we just have JN. JN is equal to this product, okay? So before I go ahead and multiply these out, I'm going to simplify this and factor out a 2 from here and factor out a 2 from there, okay? So when we factor out a 2, we're left with 1, right? 2 divided by 2 is equal to 1. And then 18 divided by 2 is 9. All right. So now that we've brought the numbers down, we can multiply these out. 3 times 9 is 27. And so JN, segment JN, I should put these marks on so that we know these are segments. Segment JN has the length of 27. Okay, so let's take a look at a couple more examples. Okay, so here, example 3. We are asked to find the length of AD for each of these triangles. Okay, so in this triangle, AD is over here, and in this triangle, AD is over here. Okay, so let's go ahead and start with this triangle first. Here's AD, and we know that this triangle, all the medians are bisecting the sides of the triangle, so we can go ahead and apply the theorem. We know that AE is exactly 2/3 of AD, okay? And we're focusing on AE because we're given what AE is. So let's go ahead and establish that relationship. AE is exactly or equal to 2/3 AD, okay? Now that we've established that relationship, we can substitute AE with 21 because that's given to us. So 21 is equal to 2/3 AD, okay? And then we can go ahead and multiply both sides by the reciprocal of 2/3, which is 3/2. Okay, and when we do, the 2's cancel out here, the 3's cancel out here, and now AD is equal to 63/2. Okay, so that is the length of AD. Okay, now let's take a look at this next example. Okay, here this one's going to be a little bit different in that this median AD, part of that median we're given DE as 12. Okay. However, if you think about this, the theorem tells us that segment AE is 2/3 of the median, right? And how do we know it's 2/3? Because it starts from the vertex to the centroid, okay? From the vertex to the centroid. So it is that portion that is 2/3 of the median AD, okay? Now, we could say this. We could say that AE is equal to 2/3 AD, okay? And that is valid. However, that doesn't really help us because we don't know what the length of AE is, okay? We don't know what that is. And we're trying to find the length of AD, okay? And we can't find AD until we know AE. So what this means is we have to look for a different relationship, okay? So in other words, if this is 2/3 the length of the median AD, then this segment would have to be 1/3, right? And how do we know that? Because AE, which is 2/3 plus 1/3 gives us an entire whole, right? 3/3. So what we could do then is establish this relationship. We could say that ED is equal to 1/3 the length of the median AD. Okay, now by doing it this way, we can now take advantage of the length of ED, which is 12. So we can go ahead and substitute that in and set that equal to 1/3 AD. Okay, now we can multiply both sides by 3 because we want to isolate AD. And when we do, we get the following. These cancel out. And now AD is equal to 36. Okay, so that is the length of AD for the second triangle. Okay, hopefully that made sense. If any of this was unclear, I would recommend that you go back to the beginning of the recording and listen to this again. Thank you.